This space rock is about the size of 6 city blocks. It has no real craters, and part of its surface is inexplicably smooth. That combination really shouldn't be possible. But here we are. This is Asteroid Itokawa, photographed by the Japanese spacecraft Hayabusa back in 2005. It's only about 500 meters end to end, small enough that if you dropped it on Manhattan, it would cover roughly from Central Park down to Midtown. Right here in the center of frame, look at the texture. Boulders everywhere, chunks of rock jumbled together with no obvious order. Scientists think that's because Itokawa isn't one solid piece of rock at all. It's a loose collection of rubble, fragments that gravity has pulled into a rough heap over billions of years. A rubble pile, which raises an immediate question. How does something like that even hold together? Now, look toward the middle of the frame, right here, where the surface suddenly changes. See that flat, almost sandy-looking patch? Scientists call it the Muse's Sea. It sits right next to some of the roughest boulder terrain on the whole asteroid, and the contrast is genuinely strange. The leading theory borrows something from your kitchen. You know how when you shake a bag of mixed nuts, the Brazil nuts, the biggest ones, always end up on top? That's called the Brazil nut effect. The idea is that when Itokawa gets jostled by impacts or tidal forces, the small grains migrate down and pool in low spots, while the big rocks stay on top. The smooth patches are essentially where all the fine material has settled. Hayabusa actually touched down right on this smooth section and scooped up a tiny soil sample, just micrograms of material. And then there's that second rounded lobe on the right, connected to the main body by a narrow, shadowed neck. The two sections look almost like they came from different places. They might have. One model says Itokawa formed when two separate rubble piles drifted together slowly enough to stick instead of shatter. That dark gap between them, the neck, is where the two halves touch. It's also where the gravity is weakest. Stand there and you'd weigh almost nothing. A gentle push and you'd drift off into space. And here's the part that sticks with me. Computer simulations suggest Itokawa has about a 1 in 100 chance of hitting Earth within the next few million years. Not tomorrow, but the math is real. A loose pile of rubble held together by nothing more than its own weak gravity, carrying grains of material that formed 4.5 billion years ago, before Earth, before the Moon, before anything we'd recognize. Those tiny samples Hayabusa brought home are literally older than our planet. That's not a metaphor. That's just what the chemistry shows. We'll be back tomorrow with whatever the data shows next. Subscribe so you don't have to remember to check.